Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss a very important geometrical term, that is triangle. Okay, now what is a triangle? Triangle is a geometrical figure, or we can say it's a closed figure that is made of three lines. Okay, so let's begin the journey of triangles. Friends, here we see different types of triangles. You just see a triangle has three sides, three vertices, and it is a closed figure. We see different types of triangles over here. Okay, these are called the sides of the triangle. And a triangle, as I have already told, that it is a closed figure which is made of three line segments. Okay, so this, and this, the three corners are called vertices of triangle, and these line segments are called sides of the triangle. Okay, so that means a triangle has three sides and three vertices. Okay, and it is a closed polygon. Polygon means a closed figure which is having multiple sides. So it is a three angled figure, so we call it as a triangle. So it has three vertices, three sides, and three angles. This we call as angle. As we have already discussed in our lines and angles topic, so we know that these three are angles. Okay, now the interior region of the triangle is called as interior region, and the exterior part is called exterior part. Okay, now let's draw a labeled figure of triangle. Here we see a triangle. Okay, I just label it. It's A, B and C. So we call it as triangle ABC, and we write it like this: triangle ABC. Okay, it can be called as triangle ABC or triangle BCA or triangle CAB. Any of them we can call it. Okay, now this and this, these three are vertices of the triangle. Okay, and this is angle A, this is angle B, and this is angle C. So we write it like this: angle A, angle B, and angle C. And suppose I wish to represent this angle, so what I would do is angle BAC. So it's angle BAC. This is angle ABC, and this is angle ACB. Okay, now there are three line segments which are forming this triangle. So the line segment AB, this is the side of this triangle, and the line segment BC, this is also the side of the triangle, and the line segment AC, which is also the side of the triangle. So we discussed vertices, sides, and angles of the triangle. Now let's discuss points and region inside the triangle and outside the triangle. Now the region within the triangle is inside the triangle, or we can say interior region of the triangle. Suppose this triangle is PQR. Then we see a boundary. This PQR is a triangular shaped boundary, and this region is interior region, and this is the exterior region. Suppose we have some points, maybe it's A, B, X, Y, Z, C. So A, B, C are the points which are lying interior in the interior region of the triangle, and X, Y, Z are the points which are lying in the exterior region. Okay, now let's discuss the angle sum property of a triangle. Friends, triangle is a closed figure, and the sum of all the three angles, that is angle A, angle B, and angle C, will be 180 degree. Is true for all the triangles. Maybe the triangle is in different shapes, but the sum of all the three angles will remain 180 degree. Okay, this can be done by various experiments also. You can draw different types of triangle, and by your protractor you can measure the angles, individual angles. Then if you are going to add them, you'll be getting the sum as 180 degree. Okay, so in every case, the sum of the three angles of a triangle is 180 degree. Now, let's discuss different types of triangles. Friends, different types of triangles I mean to say is acute angle triangle, obtuse angle triangle, and right angle triangle. So in this case, we see all the three angles are acute angles. And what is acute angle? That we have already discussed, the angles between 0 to 90 degree. Okay, so any angle, suppose we talk about angle A, it is greater than 0 but less than, angle A is greater than 0 but less than 90. Okay, so it is an acute angle. So if all the three angles are acute angles in a triangle, then we call it as an acute angle triangle. Okay, now if the angles, at least one angle, what I mean is at least one angle is exactly one angle, more than one angle cannot be of obtuse, so if that is there, then it will be an obtuse angle triangle. I just draw an image. Here we see, suppose I name it triangle PQR. This angle is an obtuse angle. That means it is more than 90 degree but less than 180 degree. So it is this triangle PQR is an obtuse angle triangle. And since the sum is restricted to 180 of all the three angles, so more than one angle cannot be obtuse. Okay, so maximum one angle can be obtuse in an obtuse angle triangle. Now, if one angle is of 90 degree, then we can call it as a right angle triangle. Just see the diagram. In this case, suppose it is a triangle X, Y, Z. We see this angle is of 90 degree. So this triangle, that is triangle X, Y, Z, is a right angle triangle. Okay, so exactly one angle will be of 90 degrees since the sum will remain 180 degrees. So more than one angle cannot be of 90 or more than 90. So there are three types of angle. Triangle, I mean to say, acute, obtuse, and right angle. Now let's discuss exterior angle property. Exterior angle property. Now what is an exterior angle? We have discussed angles in a triangle, that is suppose this angle and this angle. I call it a triangle X, Y, Z. Okay, it's triangle X, Y, Z. Now these three angles, that is Y, X, Z, X, Y, Z and X, Z, Y, these three are interior angles of a triangle and their sum, that is X plus Y plus Z, will be 180 degree. Now we see this line YZ or this line segment YZ is extended. So if it is extended, we see one more angle is formed over here. Okay. Now this angle which is formed over here is called an exterior angle of this triangle. Okay. Now we have discussed that this complete angle, this since this is a straight line, this complete angle is 180 degree. So if it is angle Z, it will be 180 minus angle Z. That means interior angle Z I am talking over here. Okay, so this is an exterior angle. Similarly, the exterior angle can be over here also and can be over here also. I just draw the diagram. Here we see the three line segments. They are intersecting each other and we are getting a triangle. Suppose this triangle is A, B, C. So this is interior angle A, this is interior angle B, and this is interior angle C. Now this part, since this line is extended, so this is an exterior angle, here this is an exterior angle, here this is an exterior angle, and even this is an exterior angles. So except the interior part, all the three angles which are formed over here are called exterior angles. Okay, and since they are forming on a straight line, they are formed on a straight line, so their sum will be 180. So this angle, the total complete angle will be 180 degree. Here in this case, the complete angle will be 180 degree, and even here. Okay. Now let's find out an important property of exterior angles. Here we see a triangle. I call it a triangle A, B, and C. Okay, and this is this line BC is extended till D, and this is a line that I have drawn parallel to line segment AB. Okay, so this is E, and this line both of them are parallel, and we can see that if line segment AB is parallel to line segment CE, then AC will be a transversal. Okay. Now we have already discussed the basic properties of angles in the case of parallel lines. So this angle and this angle, we can see a shape of Z over here. So both the angles are alternate angles. That means this angle will be equal to this angle. Or I can say angle BAC, just write it over here. Angle BAC equal to angle ACE. Why? Because they are alternate angle. Okay. Along with that, this angle, suppose I just double line, and this angle, that is angle ABC is equal to angle CECT. And why is it so? Since both of them are corresponding angles. Okay. Now suppose I call this as relation 1 and this is relation 2. Now if I add both of them, what I will get is angle BAC plus angle ABC is equal to angle ACE plus angle ECD. Okay. Now just observe carefully. Angle BAC is which angle? It is angle this, and angle ABC is this angle. That means these two angles are equal to angle ACE, that is this angle, and angle ECD, that is this angle. That means these two angles, or we can say sum of these two angles, is equal to this complete angle, and this is what it is actually exterior angle of angle ACP. Okay, that means we can establish a proof that the exterior angle of a triangle is equal to the sum of interior opposite angles. Okay, in this case, this angle, this is an exterior angle, and it is equal to sum of this angle plus this angle. So I just write it over here. It's angle ACD. So angle BAC, this angle, and plus this angle is equal to this complete angle. So we have logically proved that the sum of interior opposite angles is equal to the exterior angle. Okay. Friends, we have just proved that the exterior angle of a triangle is equal to the sum of interior opposite angles. Now, using this, we will try to establish the angle sum property of a triangle. That means we try to establish that the sum of the three angles of a triangle is 180 degree. Okay. It's a very simple explanation. Just see over here carefully. We have already established that this exterior angle is sum of these two interior angles. I just write over here angle BAC plus angle ABC is equal to angle ACD. Okay, angle ACD. Now, since this is a straight line, this complete angle will be of 180 degree. Okay, so angle ACD can be written as 180 minus angle ACB, isn't it? This complete angle is 180 degree. So if I subtract this, what I can write? It's 180 minus this. So angle ACD is 180 minus angle ACB. Now I put the value of angle ACD over here in this expression. So just write angle BAC plus angle ABC is equal to, instead of angle ACD, I am writing down this. So it is 180 minus angle ACB. So just take this angle ACB this side. So angle BAC plus angle ABC plus angle ACB is 180 degree. Okay, and these three are the three angles of this triangle. So the sum of the three angles of triangle is 180 degree, and the proof is quite simple, and if you are asked in the examination, you can do it very well. Okay. Friends, now let's discuss sum of two sides of a triangle, and we are also going to discuss that sum of two sides of a triangle is greater than the third side. Okay, we see various triangles over here. Suppose this is triangle A, B, C, and this is angle 1, angle 2, and angle 3. Okay, now if you just measure the sides AB, BC, and AC, you will be able to observe that AB plus BC is always greater than AC. Okay, it's not only of AB and BC. That means if you add up any two sides, that will always be greater than the third side. And you can measure it in all the triangles. So if you measure length AB, measure length BC, it will always be greater than length AC. Suppose I talk about this triangle. So suppose it is PQR. The measure of PQ plus measure of QR will always be greater than measure of PR. So we can say this is triangle inequality property. That means sum of two sides of a triangle is always greater than the third side. Okay, along with that, we can also say that the difference of any two sides of a triangle is less than its third side. That means measure angle, we can establish it from here. I just rewrite it over here. Measure of length AB is greater than measure of length AC minus measure of length BC. Okay, that means the difference between these two sides is less than the third side. Okay, so these are the main properties of a triangle based on their length that we have to keep in our mind. Okay. Now, which type of questions are asked on in exams? Just listen to me. Suppose I have three lengths. Say AB is equal to 3 centimeter, BC is equal to 2 centimeter, and AC is equal to maybe 5.5 centimeter. Now suppose you are asked to draw a triangle of these lengths. Okay, now can you draw that? So first of all, you just have to observe whether all these three lengths can make a triangle or not. Here we can see AB is 3 centimeter and BC is 2 centimeter. So AB plus BC measure is 5 centimeter. Okay, but the third length we are given is 5.5 centimeter. So the third length is bigger than the sum of these two lengths. So these three lengths cannot form a triangle. So you just have to write that these lengths cannot form a triangle. Okay, so these type of questions are asked in the examination. Now let's discuss some more properties of a triangle. Friends, this is a triangle A, B, C. Okay, we can see that this is the shortest length. AB is shortest length. Okay, now if AB is the shortest length, this angle, that is the angle opposite to this side, will be smallest. Okay, that we have to keep in our mind. Okay, so the side which is biggest, the angle opposite to that will be the biggest. Okay, so in this case we can see that the side AC is the biggest, so this angle will be the biggest. Okay, AC is the biggest side, so angle ABC will be biggest. Clear? So if this the side opposite to smaller angle will be smaller and the side opposite to bigger angle will be bigger. Okay. Now let's discuss one more discrimination of triangles. Friends, there are various types of triangles. That some of the triangles are having all the sides and angles equal. Some of the triangles are having two sides as equal. Okay, so what we call them, let's discuss. I just see this triangle over here, this triangle A, B, C. If all the three sides of this triangle are equal, then we can call it as equilateral triangle. It's okay, that means side AB is equal to side BC is equal to side AC. Side AB is equal to side BC is equal to side AC. So measure of all the three sides is same and we call it as an equilateral triangle. If measure of the three sides is same, then definitely their angle measure will also be same. So measure angle A is equal to measure angle B is equal to measure angle C. So in an equilateral triangle, all the three sides as well as all the three angles are same. Okay. Now just see over here, this is a triangle, say PQR. Here we see that these two sides are equal. That means side PQ is equal to side PR and the third side is not equal to them. So if two sides of a triangle are equal, we call that it as isosceles triangle. Okay, if these two sides are equal, the angle opposite to them will also be equal. So side PQ is equal to side PR. Okay, these two sides are equal. That means angle Q is equal to angle R. Okay, so this is an equilateral triangle and this is an isosceles triangle. Now, in this case, all the three sides are having different lengths. Suppose it is X, Y, Z. So, major angle XY is not equal to major angle YZ, and that is also not equal to major angle XZ. That means all the three lengths of this triangle are different from each other. So we call it as scalene triangle. If all the three sides are different, then all the three angles will be also different. So major angle X will not be equal to major angle Y. That is also not equal to major angle Z. That means all the three sides and all the three angles are different. Then we call it as a scalene triangle. Okay. So we discussed three terminologies. Equilateral triangle, when all the three sides and three angles are equal, then the triangle is equilateral. If two sides or two angles are equal, then we call it as isosceles triangle. If all the three sides or all the three angles are different, then we call it as a scalene triangle. Here we see this is a 90-degree angle, so we call it as a right angle triangle. In a right angle triangle, one angle is of 90 degree. This length is called perpendicular. This length is called base, and the length opposite to 90 degree is called hypotenuse. Okay, I hope you are getting my point. So this is a right angle triangle. So we discussed four types of triangles over here. Friends, we will be doing problems based on all these properties of triangles in our next session. So before coming to the problem solving sessions, I would recommend you to revise this particular session so you'll be comfortable in that problem solving session. Okay.